All right, guys, section 1.2, average rate of change. We're going to be talking about today how to find the slope of a function, or again, it's average rate of change. That's the same thing, slope or average rate of change. Now, you might remember from Algebra 1 that slope, if it's a linear function, we often just call it the rise over the run, or the change in y over the change in x, or we have a formula that says that the slope of a line is the difference in the y values, the y2 minus the y1, over the difference in the x values, the x2 minus x1. So let's look at a linear function real quick. If we pick any 2 points on this function here, I'm going to pick these two. To get the slope of this line, we just need to know the rise over the run. So from this point to this point, we would go down 2, that's our rise, divided by the run is to the right 1, so that's a plus 1. So over positive 1. And if we're to divide 2 by 1, we get 2. And if you divide a negative by a positive, that's just a negative. So that's our slope. Or we could say that's the average rate of change of this function. Now, it won't always be a straight line in this class. So what's going to happen is we're still going to find the slope. We're still going to find the average rate of change. But it's going to be between a couple of points. All right, so we're going to be told the x coordinates here. And so our first question, we're going to find the average rate of change of this function over here on the interval from x equals 0 to x equals 4. Those are our x values. All right, so on this graph, x equals 0 to x equals 4. Now, it's not a straight line, right? This function is curved here. So what we're going to do is just approximate. Well, sorry, let me take that back. We're not approximating. We're finding the average rate of change over this interval by just connecting those 2 points with a straight line. Okay? Now, what's the rise over the interval? We're not going up or down at all. So the rise is 0. Divided by the run, we're moving to the right, 4. But 0 divided by any number is just 0. So that's the slope over that interval, or the average rate of change. Second question, find the average rate of change of that function over the interval from x equals 1 to x equals 2. So we're going to start now at x equals 1, but we're only going to go to x equals 2 right there at that turning point at the bottom. And so again, I'm going to connect those 2 points with a straight line. What's our rise? Well, we're going down 1, 2. So the rise is down 2. Divided by the run, we're going to the right just one space here, right? From x equals 1 to x equals 2. So it's plus 1, and that just gives us negative 2. All right, so that's if we're given a graph. We're just doing rise over run. We're basically ignoring the graph except for the points on the interval. So those are the only points that matter in the first interval. Those are the only points that matter in the second interval right there. All right, now we're going to do the same thing, but with a table. And we could plot the points and do the rise over the run, or we could use our formula, which says that if we subtract the y values and we subtract the x values and we divide them, that gives us the average rate of change, or the slope. So again, these are always x values. I'm going to call this x1, and I'm going to call this x2. If it's an interval, if it's a coordinate point, that's different. But for an interval, these are always x values. So let's see. X2 is going to go first, so that's 4, minus x1, which is 1. So we need to get the y values at those x values. So let's see. When x is 4, our y value is negative 1. And then minus, when x is 1, right here, the y value is negative 2. And it has to go in this order. If I put 4 first, I've got to put its y coordinate first. Right? If I put 1 second, I've got to put its y coordinate second. All right, so the rest of this is just adding or subtracting and then dividing here, excuse me. So if we're subtracting a negative, that's really adding. So those two numbers added together give us 1, and then those subtracted just gives us 3. That's our slope, or our average rate of change here. Now, what happens if we change the interval? We're going from 0 to 4. So we don't care about this point anymore. So I'm going to cross that point out. We care about these 2 points from 0 to 4. Again, same formula here, different x values. So x2 is still 4, but x1 is going to be 0. All right, so let's see. When x is 4, y is -1. When x is 0, y is +1. Oops. All right, so if we subtract, the numerator is just -2, the denominator is 4. Now, both of these numbers here are divisible by 2, so it simplifies into -1 over 2, or -1/2. And that's our slope, or again, the average rate of change of that function over that interval from 0 to 4. All right, lastly, given an equation, how do we get the average rate of change? Well, it's the same process. We just don't have the y values, so we're going to have to figure out these y values. But let me copy that formula real quick. All right, so we're still using this formula. We're still given the x coordinates, x1, x2. But we're not given the y coordinates. So we're going to talk about if this is calculator versus non-calculator. If it's non-calculator, we by hand are just going to plug these numbers in for both x's. If it's calculator, the calculator can do most of the work for us here. But either way, I'm going to replace the x's with parentheses. And inside of those parentheses, I'm going to plug in the 2 first. It doesn't really matter the order you do. I'm going to plug in the 2 first, though. So let's see. Multiplying 2 by itself gives us 4. That gives us 8. If we subtract, we get -4. So this is our, let's see, that was our x2. I plugged in 2. So this is our y2 right here, -4. Y2 is just -4. To get y1, we do the same thing, but we're going to replace the x's now with -1. So let's replace those with -1. And again, if it's calculator allowed on Desmos, just type this in to get the y value. All right, just like before, you would have typed in this thing with the 2 on the inside the parentheses to get y2. So if I square, we get 1, and that's a +4. 1 plus 4 just gives us 5. So that's our first y value, or y1, I should say. Now all we have to do is subtract and divide. So let's see, that's -9 over, this is really a plus when you're subtracting a negative. So that would be 3. And 9 over 3 is 3, but we have a negative, so it's -3. All right, that is the average rate of change, or the slope over that interval for this function. And if we really wanted to explore this more, we would have to graph this function and confirm that if you go really down 9, right 3 from that point to that one right there. All right, guys, I hope this was helpful. Best of luck on the practice with this, and as always, stay flawless.